use alternating series test to determine if the series is convergent. Okay, due to the factor -1 raised to n minus 1, this is an alternating series, and sigma whole thing is an, and without plus minus factor this part is bn. So we write here bn's are given by n times e to the negative n, which is same as, let's get rid of this negative exponent. Okay, so n over e to the n. To apply the alternating series test, we need to show two things: bn's are decreasing and they decrease to 0. We need to show bn's are decreasing. For that, what we can do is use calculus 1. Convert this into a function fx, just change n to x, so x over ex. Okay, find the derivative using quotient rule and show that the derivative is negative for all x bigger than or equal to 1. If the derivative is negative, that means the function is increasing, the function is decreasing on for all x bigger than or equal to 1. That would work. Or in short, we can just show the next term is the next term bn plus 1 less than or equal to bn. That is the next term n is n plus 1, so n plus 1 over en is less than or equal to n over en. By the way, bn plus 1 replace n by n plus 1, n plus 1 over e raised to n plus 1. Is left hand side is less than or equal to right hand side. It's not easy to see, so let's cross multiply. So en times n plus 1 is en times n plus 1 is this part less than or equal to en times en plus 1. And by the way, en plus 1 is same as e to the n times e to the 1, right? I'm just writing n times en plus 1 in this way, and e to the n is always positive. I mean, this is true for all bigger than or equal to 1. Then e to the n, we can divide both sides by e to the n and cancel e to the n. Now is n plus 1 less than or equal to n times e, where e is an irrational number whose value is about 2.7. Is this true for all n bigger than or equal to 1? Okay, when n equals 1, this will be 1 plus 1 2, this will be about 2.7. that's true. When n equals 2, it will be 4. 2 times 2.7, it looks like it's true, or we can go further, subtract n from both sides and see is 1 less than or equal to, when we subtract e, we can factor e out, n minus 1 e. Subtract n from both sides. Okay, subtract n from both sides. This is not true. Subtract n, and then we can factor n out. It remains e minus 1 raised to n. Is this true for all n bigger than or equal to 1? E is about 2.7 minus 1, so it's about 1.7 times n. Yes, for n equals 1 times 1.7, which is obviously bigger than 1. N equals 2 times 1.7, so this is true. That means bn's are decreasing. Next, we need to show the limit of bn. Limit of bn when n goes to infinity is 0. Limit of bn n over en over en as n goes to infinity. Okay, let's find this limit. You can clearly see this is 0 because e to the n grows much faster than n. Okay, this is an identity function like ex and e to the n exponential function. When n is very big, this one grows much faster than this. Bottom becomes very big, so this will be 0. Or you can use convert en to ex and use L'Hopital's rule, you will get 0. In any case, we just showed bn's are decreasing and they decrease to 0. That means by the alternating series test, the given series converges. By the way, this test cannot be used to show divergence. If one of these two conditions fails, no conclusion.